welcome to this explainer. Today we're taking raw, textbook automotive knowledge and transforming it into an intuitive, systematic diagnostic mindset. Whether you're stepping into a service bay for the very first time or you're a focused learner who just wants to understand exactly how master technicians diagnose complex machines without, just guessing, well, you are absolutely in the right place. We're going to bridge that gap between the textbook and real-world wrenching. Let's take a quick look at our diagnostic roadmap. We're going to step through shop safety and tool mastery, break down the 4 engine strokes, cover electrical and battery testing steps, dive into some real-world diagnostic scenarios, and finally, wrap up with the preventative maintenance sequence.
All right, Section 1, Shop Safety and Tool Mastery. Let's get into it. So, these right here, these are your non-negotiable safety rules. And look, it's not just about blindly following compliance checklists. It's about understanding the why behind them. Take the battery, for instance. Why do we always disconnect the negative terminal first? Well, doing that breaks the ground path. If your wrench slips and accidentally touches the metal body of the car while you're unbolting that negative terminal, literally nothing happens. But if you start with the positive and touch the body, you've just created a massive, dangerous short circuit. Oh, and another huge one, treat every single fuel line as if it's highly pressurized until you've manually relieved it. Yes, even if the car has been sitting off for hours.
Now think about the psychology of measurement for a second. An uncalibrated vernier caliper or micrometer, it will lie to you with absolute mathematical certainty. And a confidently wrong reading is going to send you chasing phantom problems for hours, if not days. It's a complete nightmare. Always zero your precision tools before every single use.
Because really, mechanical shortcuts are a technician's worst enemy. You might think a slightly loose wrench is close enough, right? But the very second it slips, you've rounded off a bolt head, instantly turning a simple 5-minute job into a 2-hour extraction nightmare. And usually that requires a bit of a blood sacrifice from your knuckles too. And hey, take a look at your multimeter. Frayed or dirty leads will literally give you an intermittent reading on the screen. To you, that looks exactly like an intermittent vehicle fault. And boom, you are completely wasting your time diagnosing the wrong system. Seriously, keep those tools pristine.
Moving on to Section 2, the 4 engine strokes.
Let's peer inside the machine and look at the engine cycle. You've got 4 distinct strokes, but I really want you to focus on their exact purposes. Intake. That's the only stroke that actually loads fresh air and fuel into the cylinder. Then, compression. This squishes that mixture down, which is absolutely crucial because compressing it before ignition makes the resulting explosion exponentially stronger. Next up is the power stroke. This is the big one. It's the only stroke that actually produces usable energy. The other 3 literally just exist to set it up. And finally, exhaust. If the exhaust stroke fails to fully clear out those spent gases, it dilutes the next incoming intake charge. And let me tell you, that is a massive hidden cause behind a really rough idle.
So how do we actually use this knowledge when we're listening to a running engine? We use if-then logic. If you hear a ticking or a knocking sound, pay close attention to the engine load. A connecting rod knock, which originates deep down in the rotating assembly, will actively get louder when you put the engine under a heavy load. On the flip side, a simple valve tap up in the cylinder head, that generally won't change its volume much under load at all. Knowing that simple distinction will instantly cut your diagnostic time right in half.
Next up, Section 3, electrical and battery testing steps.
Okay, we're getting into the nervous system of the vehicle now. You absolutely must mentally master Ohm's law in all 3 of its rearranged forms. The real world isn't always going to neatly ask you to solve for voltage. You might have the voltage and the current, and you'll need to find the resistance to track down some corroded ground wire hidden way up under the chassis. Being able to mentally juggle this equation, it's completely non-negotiable for diagnosing complex circuit faults.
And when you're testing a battery, the sequence is everything. Step 1 is a visual inspection. A cracked, bulging, or leaking battery case is physically dangerous to test electrically, so always check that first. Step 2, clean the terminals. And again, negative first. Step 3, measure the static voltage with the engine off. A healthy resting battery should sit at roughly 12.6 volts, but do not stop there. Step 4 is the load test, and this is where the magic happens. You apply a load equal to half the battery's cold cranking amps for 15 seconds. Why? Because static voltage alone can look perfectly fine on a battery that will completely collapse under a real cranking load. The load test exposes those weak internal cells that a simple resting check completely hides.
let's think about what happens when you turn the key using that same if-then framework. If you turn the key and hear a single sharp click but the engine doesn't turn over, immediately suspect the starter solenoid or a deeply discharged battery. But what if it's a slow, struggling crank? Well, the starter is trying to do its job, but it lacks the amperage. In that case, you should suspect heavy corrosion at the terminals acting as a resistor or a weak battery that's just failing under load.
All right, let's put this into practice. Section 4. Real-world diagnostic scenarios.
Imagine this. A customer brings in their car complaining it's overheating. Vehicle speed is an incredibly vital clue here. An overheating issue that only happens at highway speeds often points directly to a physical airflow blockage. Think debris crammed in the radiator fins, or maybe an internal radiator restriction. But if it overheats exclusively at low speeds, or just sitting at idle, you should instantly suspect that the engine cooling fan isn't engaging. Because at idle, there's no natural wind pushing through the grill to cool that coolant down.
Now, I need to deliver this next pro tip with the absolute utmost seriousness. Never, ever open a hot radiator cap. The cooling system is under high pressure, which effectively raises the boiling point of the fluid inside. The exact moment you twist off a hot cap, you depressurize the entire system instantly. That superheated liquid flash boils, and it will violently erupt straight into your face and hands. It's incredibly dangerous. Always let it cool.
Okay, let's talk onboard diagnostics, or OBD. When you plug in your scan tool, your goal is to find root causes, not just read off a list of codes. Say you see a cylinder misfire, you're going to go check the spark plug, the coil, and the wiring for that specific cylinder. But here is the absolute golden rule. Never ever clear the codes before you've actually diagnosed and repaired the vehicle. Why? Because clearing the codes immediately deletes the freeze frame data. That's a digital snapshot of the exact RPM, temperature, and engine load at the exact millisecond the fault occurred. That data is your best clue, so clear codes only after the repair is done and verified.
Remember, your eyes and hands are just as powerful as any expensive scan tool. Customer complaining about poor fuel economy? Before you go diving into complex fuel injection data, simply check for a highly restricted dirty air filter. What if the customer feels a pulsating brake pedal? That is almost always a physically warped brake disc pushing back against the pads, not some weird master cylinder issue. A soft, spongy pedal? That usually means air is trapped in the hydraulic lines. An uneven tire wear? That's the road literally grinding a steering or suspension geometry fault right into the rubber.
Which brings us to Section 5, the preventive maintenance sequence.
Preventive maintenance service, or PMS, is basically a pro's secret weapon. It shifts your entire approach from doing reactive, stressful repairs after something breaks to proactive, predictable vehicle care.
This is the exact sequence you need to follow, in this specific order every single time. First, record the customer's concerns to guide your focus. Second, change the oil and top up the fluids, because discovering low fluid is often the earliest warning sign of a hidden leak. Next, check the filters, then test the battery and the brakes. And finally, step 6, document everything. Seriously, a thorough but undocumented inspection is treated as an incomplete one. Your documentation is your proof of work. And spoiler alert, it's exactly what gets graded if you're ever on an assessment.
Let's talk about a couple of precise mechanical inspection shortcuts. When you're checking a drive belt, don't just look at it. Grab it and do a flex test. A slipping, glazed belt can look perfectly fine to the naked eye while secretly underdriving the alternator. Also, always check tire pressure when the tires are cold. Driving generates heat. Heat expands the air inside, and that expansion will completely mask a dangerously underinflated tire.
And here's a crucial reality check for you. The PMS sequence itself is heavily scrutinized. Assessors, and shop managers for that matter, aren't just watching to see if you know what a brake pad looks like. They are watching to see if you can manage a reliable, repeatable checklist under time pressure without skipping any steps. Nailing the sequence literally proves your competence.
And that brings us to the end of our roadmap. We've covered the strict safety protocols, the math behind electrical faults, and the exact steps you need to systematically isolate complex problems. You have the master technician's blueprint right in front of you. So, here's the question. When you step into the bay, will your next diagnosis save the customer or leave them stranded? Keep these strategies in mind, trust the sequence, and never guess when you can test. Thanks so much for joining me on this explainer, and I'll catch you on the next one.